Guiseppe Medeghini. I'm HVAC engineering and energy consultant for Planning Studio, and I will be very quick to explain what we do, why sustainability is very important to us, and what we do to help our customers get sustainability. So just to get onto the problem. So what's common to our cities, so to Milan and London? Well, is fog, but smog as well. So pollution is a big problem as fog in Milan and in London. So where is it coming from? Yeah, of course, it's coming from traffic. Traffic is a very main big source of pollution, but it's coming from businesses and residential as well. So 66% of the total is coming from business and residential. As we've seen before, 45% of this is due to HVAC system. So HVAC system is the biggest polluter on Earth. So if we go ahead, we can see the average house actually consumes twice as much as the average car. So we've done a lot for cars, but we've done nothing basically for houses. And where is coming this pollution from? Well, it's coming from energy production. So we use carbon, we burn coal actually to produce energy. It's coming from gas boilers. So to heat up our houses, we use the gas. And even when we have like a combined energy and heat production, it's still more efficient, but we're still burning and we're still emitting carbon dioxide. So European Union and UK did something about it. So European Union defined that by 2020, all new buildings will be nearly zero energy. UK did even better. So by 2016, all new homes, 18 domestic schools and hospitals, and 19 is all the new buildings. So we have to do something about it, as we were talking before. So how do we do it? Of course, energy production for lighting, for example. We can use energy like geothermal, solar photovoltaic, hydroelectric, or wind. So we can produce with renewable energies. But what can we do for heating and cooling? Well, we can use this, a fridge. Can work it out. But a fridge works with a very simple principle. It doesn't create cold, of course. It just pumps the heat out from the inside to the outside environment. So using a little bit of energy. So it's an heat pump. And we can apply the same principle to a house. So during the summer it's exactly the same. We pump the heat out from the inside environment to the outside. And during the winter we do the other way around. And a heat pump is very efficient. It is very efficient. For example, the air heat pump the efficiency gets lower if the outside temperature, air temperature is lower. So the lower the outside temperature is, the lower the efficiency is. But we can use other sources as well. For example, water. So if we use water, water is always between 12 and 16 degrees average throughout all the year. So we have very high efficiency rates. And we can use other sources. So we can use earth, water, or air. And these sources are actually renewable. As the European Union says, and as each country in the European Union says, there is actually a percentage, this majority, that is calculated, like for air, heat pumps, for example, is about 75%, 70%. There is actually renewable sources. So we're heating our houses with renewable sources, just using a fraction of the energy. And that fraction of the energy can come, for example, from other sources, from photovoltaic system, or we can have a deal with our supplier for using renewable sources. So it could be 100%. And these technologies are actually really available on the market. This, for example, but it's not a brand new technology, something that has yet to be created. So there must be something that doesn't work. Is it expensive? Actually, it's not that expensive. It's actually the same price as having, for example, a gas boiler and a refrigerator. So if I have a heating and cooling demand, I still have to have a gas boiler and a refrigerator. I need double the space, I need the chimney, fire prevention is a big problem. So pretty much at the same price. And what about, for example, efficiency rate? So without energy production on site, we have gas boiler is pretty much very efficient, about 100%. But if we go to air, for example, water heat pump, we get to 150%. If we go to geothermal, so closed loop, open loops, we get up to 200%. And this is without energy production site. So we're taking into account that the efficiency of the grid, so the efficiency of production, energy production in the UK, and delivery, and the losses connected to it. So what if we are actually producing energy on site? We have, for example, the photovoltaic system on site, we're producing energy. We get this. So it's very, very efficient. Gas boiler is still there because we cannot use electricity produced by the photovoltaic system to help our gas boiler, but we can help our other, for example, the heat pumps. And going on, for example, We can have office buildings or hotels, for example, development. There's a south side and a north side. And during, for example, mid-season, April, March, the sun comes in. On the south side, it gets warm. We have a cooling demand. On the north side, it's pretty chilly because outside is still chilly. And we have an heating demand. So what if we apply a heat pump between the south side and north side? So we just pump the heat from the south to the north. Actually, we get this. So we get an efficiency rate that is stunning. So we're just using a fraction of energy to actually moving the heat from one side of the building to the other side of the building. So it's a very, very efficient solution as well. So moreover, we have incentive schemes in the UK as well. There is the renewable heating incentive scheme and the feed-in tariff for the solar photovoltaic system. Gives a little bit of money, but it's still something to add on the pot. So now I would like to talk to you about what we call our sustainable process. So how we help our customers to be more sustainable, how to help them to have like a sustainable design in their buildings, in the building process. So first of all, we start with the envelope design. So we start minimizing the energy need of our building. So for example, there's a shade analysis. We want the sun to come in during the winter because it helps our heating system, but we don't want that during the summer because we have a higher cooling demand. We have a deep study of thermal bridges, shape analysis, and we develop like insulation as well. So insulation is a big problem. So we minimize the heating and cooling demand. After this, we design the HVAC system. So we want the highest efficiency in the HVAC system, so much advanced design. And we simulate that. So we create a model, a static and a dynamic model, and we simulate the building with the HVAC system, and we simulate the cost, the running cost that this building will have in the coming years. And that's why we like to work with Climavenit as well, because each building has specific needs. So sometimes you need to change something, and you have to be flexible with the solution. And we like to work with them because we can find always new solution to be more efficient and to have the perfect solution for the buildings. After this, we actually apply renewable sources to help to supply the remaining demand, the energy demand of the building. For example, solar thermal, solar photovoltaic systems. And the last bit is the design implementation. That is a tough part. So we follow our customer on the building side. We follow them every day. We update the model, so we are 100% sure that what we would like to have, what we thought will be delivered. We have to be guaranteed. We guarantee the certifications, the green or the LEED certification, for example, and we test the machine. That's another good point of Climavenit because we can test their machine. The machine actually is going into the field with the customer. We can have a witness test. We can be 100% sure that that machine will perform as we designed, as we thought, as it would be. So now, a few use cases of what we've done in Milan. For example, this is an old office. It was the main Italian post office building in Milan, built in the 1930s. If you've been to Milan, it's just next to the train station, the main central train station. It's the same architect for the train station. It's similar. This one has been built by Heinz and has been developed by Heinz. It's been finished in 2011. So it's very tough during these years to lease offices, as many of you probably will know. It's an energy class B, air to water heat pumps, and has been completely leased. And it's been completely leased to international companies like Disney or Amazon. So you can see that actually these companies will look into something that is efficient. Even with an old building, it's possible to create something efficient. This is the World Journey Center. It's been like from 2007-8, the end of the project. And air to water heat pump is very interesting because this is a solar photovoltaic system integrated into the facade. So it's actually production on site that is actually used for the climatization, also for heating and cooling. This is Porta Vittoria. This is under development at the moment. It's this big chunk of the city. And it's very interesting because it's a mixed-type development. We have everything. We have residential buildings, we have a 5-star hotel, we have a big supermarket chain, we have offices, we have a fitness center, we have a few shops. So there is everything. And here, what we use is water-to-water system. It is a little bit more efficient. And because we have water is really available, so there are pumps, there is a loop, the water goes around to all the buildings, and there are heat pumps for each building. So it's an energy class A and has solar photovoltaic system connected to it as well. And the last one is Porta Garibaldi, is under testing now, is the highest skyscraper in Italy, and uses air-to-water heat pumps as well, plus solar thermal and solar photovoltaic system. Even this is, uses heat recovery as well, because as the few of the previous ones, because you can see it's a glass building, so you have like double south side, north side problem. So it's very, very efficient system. And why we're here? Because we think that what we learn and our know-how that we learned in the past few years in Milan, because since 2007 it was compulsory the energy classification for buildings, so we built a know-how. Maybe the first time actually say we are a little bit advanced on this field, and we would like to apply that maybe to London. And I had a look into what the conditions are in Milan and the conditions are in London, and I was surprised at what I actually discovered. This is the average temperature in Milan. You can see there are some lower points in January, December, and some higher peaks during the summer, so June, July, August. And as I said before, air-to-water heat pumps, they have lower efficiency with a lower temperature, and lower efficiency during the summer with a high temperature, so the other way around. And this is the air temperature, and what we have in London is this. So it's much better, because you don't have the peaks, you don't have the negative peaks.
That isn't much better. We'd rather have it. We want the peaks.
Well, it's very hot during the summer. Really, Milan in August is not that nice. I'll invite you next year.
It is a different way of looking at it.
It is very, very hot.
We are so lucky.
There you go.
So the temperatures are much better. So the efficiency rate you can actually get here in London are much, much better. And what about water? In Milan we're pretty lucky, let's say that, because we have an impermeable bedrock that is quite close to the surface. So the water gets stuck between this layer and the surface. So it's very easy to find water. So when actually you have to build, like, for example, a car park, an underground car park, one story, 2 stories underground, you still have to pump the water out, otherwise everything will be flooded. So you just pass this water through an heat exchanger, and you have your water-to-water heat pumps. So you already have that energy, you have just to use it. And when I actually looked at London, it's really surprising, but it's exactly the same. You see the orange bits are all impermeable bedrock. And from the 60s, because before there was the industry were using this water for, they were consuming a lot of water, it's been recovering by 3 meters every year. So now it's pretty much the same situation as we have in Milan. So what we aim to this. So we aim to turn things around. We think that to be more sustainable, you have to have sustainable buildings. Buildings are the main source of carbon dioxide emission in the world. So if you really want to be more sustainable, if you really want to have a more sustainable business, if you really want to be a sustainable business developer or leaser or hotel manager, you have to have a sustainable building. And what we want is this. So what we like to have is really a city without carbon dioxide emissions. So we have a city that is completely sustainable, is green, is the air, is no more pollution, and the air is very enjoyable as well. So these are my contacts. If you want to write me, ask any question, feel free, and I hope that we can help. At the end of the day, to make you fall asleep.